Alright, so what we decided to take on as our project, our mechanics, was to look at the coefficient of friction within a skateboard and a skateboarder. So what we did, how we approached it, was take a trip down to the local skate park, and at the skate park there is a pool. And we asked them to, without pumping, without adding any energy, as well as they could do that, to start on the side of the pool and then just let energy take its course. Then what we did was we used tracker to track a point mass on our skateboard. At the highest point, he's not moving. So all of his energy must be held in potential energy. If he's not moving, there's no kinetic energy. And the same thing is true at the other side, right? If he's not moving, all of his energy is held in potential energy. So what do we know about potential energy? We determine the height at this point. So how do we calculate the amount of energy he's losing? Well, it's the difference in the potential energy held at this point compared to the potential energy held at this point. So that's the energy that was the change in energy from this point to this point. And that's going to be also equal to the energy lost to heat through friction, right? These are our two, potential energy 1 minus potential energy 2 is going to equal our change in energy. And we get our delta energy equals 28.8 joules. So this became heat energy. So we used an energy lens to determine our change in energy from one point after, and then he passes along the pool to another point. We know that our change in energy is going to be equal to the work. Well, okay, big deal. Well, what does work equal to? It's going to be equal to force times distance, dx. So this we can say the force of friction times the distance that our skateboarder traveled is going to equal our change in energy. And 28.8 joules equals the force of friction times 4 meters. And we'll explain this 4 meters when we're done. So this gives us that the force of friction equals 7.2 newtons. We know that the force of friction equals mu times the normal force. Alright, so if we can determine that mu times the normal force, our force of friction, equals 7.2 newtons, then we can just divide by our normal force to get our coefficient of friction, which is what we're looking for. But the thing is when he's in the pool, the normal force is changing, right? Because when he's at the bottom here, when it's flat, he's not accelerating in the y direction. The acceleration in y direction equals 0, so the sum of the forces must equal 0. So therefore, in the y direction, the normal force must equal the force of gravity, mg. But then when he's all the way up on the side, when the side is vertical, he's not accelerating in that direction. So the normal force is small or close to 0. It's negligible, right? When the mg is still acting on it. So if we can compare the amount of time that he spends on level ground compared to how much time he spends here, and realize that the normal force over here is going to be so small compared to the normal force when he's on level ground, we can kind of approximate and say that he's going to lose 90 to 95% of his energy to friction when the normal force is greatest, when he's in these 4 meters, right? And that's why we used 4 meters as our distance traveled, right? Well, what does the normal force equal over these 4 meters? Well, if it's level and he's not accelerating, then the normal force must equal mg. Is equal to 720 newtons. So then, when we divide out and substitute, the coefficient of friction is 0.01. This makes sense, right? Because this is a really small coefficient of friction. And your experience with skateboards is that they're meant to roll, they're not meant to slow you down. So having a small coefficient of friction makes sense. So using energy and our displacement to find how much energy was lost, and then we use work to determine how much energy was lost to friction, right, over our distance. So then we can find how big our frictional force was. Then we can determine our coefficient of friction from that.